side. Okay, so guys, team today's topic is on outlier detection and treatment. Okay, this is part of the uh, the roadmap of EDA. Okay, so we have done data understanding, missing data analysis, data type and consistency check. Yesterday we did descriptive statistics. Today's topic would be outlier detection and treatment. Okay, so the focus area will be identify anomalies. Okay, we will use box plot. Box plot visualizations are very famous for identifying the outliers and IQR, okay, interquartile range also, which is min max and Z score. Okay, this Z score we will touch these topics in advanced Python, or we can call it as machine learning. Okay, and then followed by univariate analysis. By univariate means single column analysis, bivariate compared to variables. Okay, so we can do correlation, scatter, pair, and cross tabs. Okay, this will be very useful, guys. Okay, so you will encounter with categorical and numeric data. So you will know how to treat, how to deal those kind of data, and then multivariate. Okay, more than 3 or 5 columns or 6 columns. We'll learn about heat maps, pair plots, and PCA. Okay, so PCA stands for Principal Component Analysis. We'll see how to apply this and what are the benefits of PCA. And then finally we have feature engineering. Create new useful columns. Say you have 3 columns here. Okay, step, focus area, and description. Okay, out of these two, you are making some sense with the data, right? So you'll create one more column, and then you will create a ratio, flag, bins, encoding, categorical, and all you'll do. Okay, so you will learn about feature. This is called feature engineering. Okay, and finally we'll end this EDA with data visualization and insight. Okay, telling a story. How to we need to learn the technique of telling our story. Okay, a data story. What our data speaks. Okay, through visualizing trends, correlation patterns for decision making. Okay, so get back to this Jupyter notebook. So today's topic would be on uh, outlier detection and treatment. This is one of the roadmap, okay, of EDA, okay, or I can say life cycle. Okay, what are the life cycle of EDA? These are 10 steps: understanding data, missing data type, consistency check, descriptive, outlier, univariate, by multivariate, feature engineering, and finally you close with data. Okay, this is a life cycle of EDA, exploratory data analysis. Okay, so first thing first, I want to know what is outlier. Okay, what is outlier? Okay, in simple terms, I can say outliers are data points. Okay, you have some data points. Okay, so I'll take some data points. Okay, randomly I'll take some data point. Okay, so outliers are data points that differ significantly from the rest of the data sets. Now, if you see here, most of the data sets that we have is double digit 1, 2, 3, 4, 5, 6, 7. Okay, and rest 1, 2, this is 3 digit and this 4 digit. Okay, now if I ask you simple terms, what is the what numbers are outliers here? I can say simply this number, and this number. Okay, so rest 43, 55, 66, 77, 88, 16, 33. This looks normal to me. Okay, so like I said, outliers are data points that differ significantly from your rest of the data set. Okay, we'll have some hands-on also today. We'll do that, and then we'll get an idea. Okay. Okay, and In the previous example I showed you, right? It could be too high or too low. Okay, compared to typical data value. Say for example, you take class 10th students. Okay, height. Okay, okay. So there are 10 students. So I'll just add their height. Uh, 5 feet 2 inch, comma 5 feet 2. Okay, 1 minute. 5.3, 5.1, 1. Okay, 1, 2, 3, 4. I'll take one more. 6, 6 feet. Okay. Now, if I ask you, what are which age group is the outlier here? I can simply see these are all matching except this 6 feet. Okay. There can be exceptions sometimes. There are people who can be over height. Okay, but in our data sets, so this is how you're gonna find out your data, sorry, outlier in your data sets. Okay, this is one of the uh, very simple and easy way to find your outliers. Okay, using box plot. Okay, then IQR. Okay, and there are different techniques are there. You can use any of those techniques uh, to treat your data. Okay, so too high, too low. Okay, and uh, so what causes this numbers, right? It could be data entry errors, measurement issue, maybe it was not measured properly. Okay, or genuine rare events. Okay, it could be any of these uh, reasons, guys. Okay. Okay, and this one is the second point. And in simple example I can give you is if a student scores between 60 to 90. Okay, most of the students are scoring between 60 to 90, but one student scores 5 or 99. Okay, we can simply say these are the outliers. Okay, now you see what are the impact areas. Okay, so when you have an outlier in your data sets, your mean will be distorted. Okay, the average. Okay, so the simple examples I gave you just now will definitely will give you a wrong mean distortion. Okay, outliers can shift the mean, misleading conclusion. So you are finding out the mean in your office. Okay, who is coming to work or not. Okay, because of one or two outlier number which was typed incorrectly or which were captured incorrectly. Okay, will definitely lead a bad decision. Okay, that is why we say outlier detection and treatment is very important. This is one of the step in EDA. Okay, exploratory data analysis. Let's write down here. Okay, mean distortion. Okay, next one is model bias. Okay, machine learning models like regression becomes biased. Okay, if you have the outlier, so that is the reason we say we have to say, for example, in manufacturing unit, right? You are manufacturing some product. Okay, XYZ product, so definitely it goes through quality check, right? So the height of the product, the size of the product, the weight of the product, the color of the product, right? All these goes under uh, supervision, right? So it goes through strict supervision to make sure it passes through quality. Okay, if not, what happens? See, in this case, we cannot say any machine learning. Definitely, there is a customer dissatisfaction when he gets, okay, see, the shape of the product is somewhat tilted or whatever it may be. Okay, so you're gonna see some impact on the customer, whoever is buying. See, if you see this company called car manufacturing company Toyota. Okay, Toyota has a very strict quality check. Okay, and whatever the see, I can say Toyota and both are Japanese companies, Honda. Okay, these two companies, if we see, their product is very reliable in market. Okay, you can just close your eyes and you can believe that their product, once you buy it, right, you don't have to think about anything. Okay, you can go long drive or anywhere, right? It is very reliable. The engine will not stop or crash or anything like that. Okay, so those two, I mean, manufacturer like Honda and Toyota are very reliable. Okay, because they have some Six Sigma concepts, right? So all their product, each and every car goes through the quality check process. Okay, so whether the handle, the tire, or the glass, whatever, okay, car components are as per standards. Okay, otherwise what happens is, if I buy a car and tomorrow if I see the gear handle is little tilt or bent, and it's a dissatisfaction of customer, right? So which they don't want to do that. Okay, similarly here, model bias, same thing. Okay, instead of model, you can add here is customer is dissatisfaction. Okay, and data visualization, scale distortion hides key trends. Okay, so if you have a high scale or low scale, it hides some trends, right? It will suppress your entire uh, trend, and then you will be not able to judge what you have to do next. Okay, you might take a wrong decision which will directly impact your what do you call the decision and other things. Okay, business decision outlier may represent errors or critical insights. Same thing I just explained. Okay, so what are the techniques? Okay, what are the techniques are there for detecting outliers? Okay, we'll see. Okay, so what are the techniques we have? I'll take a sample data first. Okay, so I have written already in a notepad. Same the student and marks only. I just copied whatever I need for our sample. Okay, now these are the libraries that I'm importing. Pandas, you know. Okay, and NumPy is for numeric computation. Pandas is for data manipulation. Seaborn for your visualization. Matplotlib is also for visualization. Okay, and I'm creating a dictionary data type, student and marks, two columns, and these are the some data. Okay, now you see here I have all the data. You see one order, right? But you see 120. So 120 is an outlier, simple, I can see. But see here I have how many column? 10, right? Sorry, how many rows? 10. But what if in real time when you have a 2000 rows or 10,000 rows, can you go scroll up and down and find out? No, right? So that is the reason we have some tool sets that we have to use and identify our outliers. Okay, so I'll run this. Okay, so these are my data set, students, some random names and some marks. Okay, so I know by seeing these 10 columns I can say these are outlier, but we'll find out. Okay, so what is the first method that we're going to use? Okay, using box plot. Okay, and we will use something called visual detection. visual detection. So just run this. Okay. So first thing what I'll do is, so I have this data set and I can see my data here. Okay. Now what I'll do is I'll do the visualization to plot a this one box plot. So I'll use SNS dot box plot is here. I'll use the box plot. So box plot will take the y-axis. Okay. Y equals I have what df dot bracket inside I'll use marks. Okay, column. Now here you see I'm just picking up one column only. I'm not picking up all these things. Okay, only one column. Okay, and then I will give a title here, plt dot title. Okay, plt dot title, and I'll just give a random heading called box plot for outlier detection. Okay, and then plt dot show. These are the standard commands. Okay, run this. So it says df dot. Okay, no dot. Sorry, it is like this. Okay, now you see. So this is the whisker. Okay, this is called whisker, and you see this point is at the middle. Okay, whenever it is slightly up and down, you will see your data dispersion right skew or left skew. Okay, yesterday we have seen. Now you see something called one point here. Okay, so this point that we are talking about, this 120 value, is an outlier. So in box plot, simply it will show you have outlier or not. Okay, now if you see all your data is, if you see all your data, okay, you forget about 120. If you see all your data is spread equally, okay, 86, 84, 87, 1 point. Okay, so if you see the difference, okay, if you take the mean also, you'll see, and standard deviation. Okay, I'll do the standard deviation. df dot describe. Okay, simply I'll use this describe and run. Okay, now you see count is 10, mean is 90. Okay, average because of this 120. Okay, what if I change this 120 to some nearest number? Okay, then this will come down because you see all your data are at 88, 85, 86, 87 and all, right? So now you see your average is, because of 121 value, it is going to 90. Okay, and standard deviation 10. Okay, right now it is because of this one value. Okay, what is the minimum value? 82, and max is 120, and 75 bucket, if you see this number, 89, 87, 85. Okay, now with this visualization you can see whatever you see, okay, outside of this whisker or this whisker, if there is a negative number, it will come down here. Okay, if it is a positive, it is coming here. Okay, it goes like this, uh, negative and positive. Okay, scale, same like scale. Okay, so anything that falls under within these two whiskers, okay, this is 25, this is 50%, and this is 75%. 25, 50, 75. Okay, so these three lines. Okay, and anything within this whisker is also uh, 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 we are okay with that data also, but anything out of this and this area, we call that outlier. Okay, right now we have just 10 rows, guys. That's the reason we are able to figure it out easily without even box plot. Now what is the inference you can draw here? One is, okay, so if you see the IQR interquartile range, so all data are within that range except one. Okay, dots outside whiskers are potential outliers. This one, this is called whisker, these two lines. Okay, and marks 120 will clearly, you can see, appear as outlier. Okay, so I'll just write the inference here. Oh, already is there. Okay. Okay, so this is my inference for this data set. Okay, now we'll see method 2. Okay, method 2 is what? Method 2, this is first method, right? So I'll just copy this. Okay, method 2 using IQR. Okay, IQR. IQR stands for interquartile range. Okay, interquartile range. Okay, so this is quite tricky here. So we will create one Q1. Okay, Q1 is quartile 1 equals DF. Then I'll take very square bracket. I'll take marks dot dot QU, yeah, quantile. Then I will use, sorry, I'll use 0.25. 0.25. Okay, this is my first quantile. 25, 50, 75. Okay, so this is, or I can say 75. 25 in between and 75. Okay, that also I can do. 75. This is Q2. No, no, Q3. Yeah, Q1, Q2, Q3. Q1 is 50. Okay, Q2 is 50, Q3 is 75. So I'll use 75 here. Okay, now what is the IQR formula? IQR formula is Q3 minus Q1. Okay, this is a formula. So I am subtracting here and I'm storing that value here. Okay, IQR marks. Okay, the value that are there in marks, it will do automatically. Okay, you don't have to worry. Now we have something called lower and upper band. Okay, so like this is lower band, this is upper band. Okay, so you can do any method. Okay, there is no hard and fast rule that you have to use this. Okay, you can use the box plot and close the this one. So lower underscore lower bound. I'll say lower bound. I'm creating a variable. Okay, lower bound equals Q1 minus. This is a formula, guys. Okay, Q1 minus 1.5 into, where is into? Yeah, into IQR. Okay, IQR. Okay, this value. Okay, same thing I'll use for upper band. Okay, upper band Q3. Okay, not 1. Q3 minus, sorry, Q3 plus 1.5 into IQR. This is the formula generally we have to create. Okay, earlier we used to do this, but since after the box plot is there, I use this only box plot most of the time. Okay, or Z score. Okay, so I use this most of the time. Okay, but this is just for your learning. Okay, okay. See, whatever sheets the Jupyter notebook that I'm sharing you, right? You have to keep it safe somewhere. Okay. So whenever you get the scenarios like this, just copy the code and change the data frame name and the columns names with your actual, and then you can get going. So I'm creating a variable called outlier, and I'm going to store what? df df square. Okay, I'll say df of df of marks. Okay, less than lower bound statement. Okay, this variable. So I am calculating if my marks is less than lower band. Okay, lower band, then I have to 1 minute less than. There should be space here, less than lower bound. Okay, and here I have to put this in uh, plain braces, otherwise it will throw an error. Okay, and second statement, I'm using a pipe symbol here, which is like a line, okay, above your enter key, the pipe symbol, and I am writing another one which is greater than. So I'll just copy this entire thing, okay, and I'll do a slight change here. Df marks is greater. Okay, and what is the next one we have here is upper bound. Upper bound. Okay, so this bracket opens here, and this bracket closes here. Okay, so this will be stored here, and then I'll write down my print statement. Print outlier colon n. Okay, on a new line I want the outlier details on a new line, comma, and I'll print my outliers. Okay, let me run this. Okay, now you see, simply I got one. Who is the outlier here? Vikram. Simple, right? But we have to write so much of code. Okay, so see, this will be always same, guys. Okay, only thing is here you have to pick your columns, what columns you have, age, timeline, okay, or whatever. Okay, it should be quantitative, not quali. It should be yeah, quantitative, not qualitative. Means categorical you cannot do computation, right? You cannot multiply the string values and all, it will throw an error. So just make sure if it is numeric, you are good to go. Just simply see, I got the name also here. Similarly, if you have more, it will throw more people. Okay, so I will add for our example Amit. I'll say Vidyushi. Okay, Vidyushi, comma 180. Okay, I'm just adding just for our example. I added just one more entry and with this value. Okay, I'll run this. So again, you have to run this, then only you'll get the proper analysis. Okay, now you see the mean earlier it was 90, 98 because of that outlier, this number. Okay, it has increased my mean value, average. Okay, and then now you will see two rounds. Okay, see, one is at 120 and one is at 180. So this is how it changes. Okay, and then now here if I do this, I'll see two rows. Okay, clear, guys? Yes, no? Okay, this is very important, very important. They'll ask you in interviews. Okay, uh, next one we will use something called z-score. Okay, so I didn't prepare the z-score definition. I'll just go through because anyway we're gonna cover this in our uh, advanced Python or machine learning. Okay, we're gonna learn uh, supervised, unsupervised, and other reinforcement learning methods. Okay, so z-score is a statistical measurement of score relation to the mean in a group of scores. Okay, so this is the actual, if you see, sorry, 1 minute, this is taking to some video. I don't want video. Um, okay, hope, let me just maximize this. Yeah. Okay, now if you see here, okay, this is I mean, this is how if your data is distributed or dispersed, okay, normally you'll see something like this, bell icon, okay, and this line that you see here, it never touches, okay, so this is one section, okay, this is, see, yeah, this is one section up to this. Okay, this is one section, 13.59, and this one is the middle mu. We called it as mu, okay, mathematical function. And this is one section, and this is one section, 2.14. Okay, so this is where your data is measured based on the values, and we'll see whether your data is dispersed equally or not. Whenever there is a this skew on the left side somewhere here, then we say it is left skew. If it is right, we'll say left right skewed. Okay, anyway, I'll add this in our this thing, read it. Okay, anyway, we're gonna do this in our upcoming sessions, but I'll just add it. Okay, method 3 is z score. Okay, and okay, and I'll add the link here. Add the link markdown. Okay, so this is the link. When you click on this, you can go and read at your leisure. Okay, these are very good concepts, guys. Okay, so you can use this method only if you're comfortable. If you are comfortable, use this one or this one. Okay, it's up to you guys. So we have three methods. So how do we do that? We have to import a different library which is called scipy, scipy. Okay, from scipy, import stats. Okay, this is the library for z-score I have to load. Okay, and then I'll say df marks. Okay, df marks. mm, no, okay, I have to copy this. This is not mark. I'll say z score. Okay, some name z score, one variable. Okay, so I am creating one column called z score. Okay, right now we have student name. Okay, we have student name and marks. Okay, I'm going to create one column called z score. You'll see one thing called z score here. Okay, that is what I'm trying to do. Z score equals, I'll say stats dot, so I'll use the 1 minute, why it is not coming, stats dot stats. Okay, I have to use something called z score. Okay, stats dot z score is a function of what? Df column of marks. Df column of marks. Okay, next line, I'm gonna calculate my outliers equals uh, df df okay df data frame uh, not marks z score, this one. Okay, just make sure you type the correct lower or upper case. Okay, case is very important. If I type this small, it will throw an error. Okay, so df of df z score. Okay, and absolute dot. We have something called 1 minute. Why my auto this thing is not coming? 1 minute. Okay, I think the kernel is busy. Why? 1 minute, guys. I need to break it, restart. Okay, just make sure if something you see busy, something is the issue, something is running. Okay, maybe you clicked on something and it is doing. Okay, it should be idle, idle state when you are writing your code. Okay, now I should get dot. Oh, okay, I clicked on tab, it is going, but it is not picking up the shortcut. Okay, that's fine. I'll do one thing. Mm, mm, it should be ABS greater than. Okay, and then I'll use the print method to display outliers. Okay, I'll just copy this. Okay, here outliers S is there, so I'll write the S here for this variable. I'll run this and let's see. Okay, df is not defined. Df is name df marks mar. Oh, okay, I just if you remember, I have just restarted the kernel, so it will lose all this from the memory. Okay, so if I run this now, I should be okay. Where is the this one? Now it should work. Yeah. Okay. So columns, the student marks and z score. Okay. So greater than outliers. Why we are not getting index here? Why 1 minute outliers? DF of ABS z score. Hmm. Okay. So I'll check this, guys. Okay. I don't want to waste time. Maybe some libraries not for outliers. You're not seeing any error, but I don't think we made anything. We have marks column and then z score we are storing here. Okay. So if I copy this, okay, I'm getting a value here. Okay. So it is checking whether it is greater than 3. Okay. So all are going in minus. Okay. Actually, you should get an index here. Okay. Then outliers. I'm getting this. Okay, new column is coming up, which is good. But why this is not calculating? Some formula we made a mistake. Uh, no. Okay, I'll figure it out. Okay. Tomorrow I'll figure it out. I'll not waste time because we have one more topic. See, right now we played with numerical. Okay, now we'll play with categorical. Okay, categorical. Same thing. We'll play with categorical. Quickly we'll do. Okay, now you see I have two columns, employee and role. Okay, these are the people's name and these are their roles in a company. Engineer, intern, analyst, blah 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 is there. Okay, and I am creating a data frame here and I'm using something called data df2. Okay, because df is already created here, I can say df1, no issues, or df2 only I'll use. Okay, and we'll see value count and all, then we'll find out some outliers in categorical. Okay, so you see here value count I'm using here. So how many engineers are there? Four, analyst three, manager one, CEO and one intern. Okay, okay, now if you see here, by seeing this value you can see engineer, analyst, manager and intern all are same category. Okay, almost, if you see their job role, but CEO is the person top of your hierarchy, right? Top hierarchy person or in a company, and I can simply say by saying this is a outlier simply. Okay, so you don't need to do anything here, and I can use normalize. Yesterday we learned, right? Normalize equals to. Let's see. Okay. So normalize will convert into point. Okay, in percentage. 43111. Okay. You can remove this one also, and you can. So you have these options. You can make use of all this. I'll just paste it here, and I'll just remove the one. Did I copy? Copy. I'll do without a normalize. Okay, you can see the difference. Okay, and you can do with actually I forgot one more here. Can also do the hist plot. Okay, pair plot, hist plot. Okay, okay. So this is a pair plot. You can see all these numbers are somewhere here matching, but there is one. So there is a outlier. These two. Okay, all are of the same range. Other numbers you can see here. Okay, if all numbers are within, you can see a dense dots here, right? So if all are falling here, but how many outliers are? One, two. Okay, same thing. So these are all very important, guys. Okay, so easily you can find out your outliers, and you can see these are the outliers, two outliers, and rest you see this level, this level, this level are all point, and you see this is left skewed. Data is left skewed. Okay, using this also you can do. Okay, so I'll just add this summary, tips and summary. Okay, so always visualize data before removing outliers. Okay, visualize hist plot, pair plot, box plot. Okay, you will get your outliers there. Okay, and you know how to treat them. Okay, so there are different methods to treat your outliers. Okay, you can remove them, you can drop them. Okay, and you can delete that entry itself. And there are some combined methods like IQR, interquartile range plus z-score. We just saw, but z-score we didn't get the no error, but I'll figure out why. Maybe some minor issues might be there. Okay, and more robust detection. Normalize before applying your z-score. Okay, you have to normalize your data before you apply. Okay, otherwise what happens is you'll see a scale difference affects results. You'll see a different scale in terms of number. Okay, So if I uh, and one more thing is there. Okay. Sorry guys, I was talking on mute. I just muted myself and then I was talking. So this is about your outlier treatment, detection and treatment. When we do this live data analysis, these are sample data, right? So a small set of data, we took it for learning. But when we do some data sets, then you will get a correct idea. Okay, let me do one thing. Let me share this sheet. So this is called EDA 09. Okay, I have shared you the um Jupyter notebook. Save it and then you can practice it. Okay, so tomorrow what we'll do is we'll do univariate analysis. And then I'll try to see if I can cover these three topics. Okay, and then we can do Thursday on feature engineering, and next week we can on Monday we can do this topic, data visualization and insight, and close the EDS session. Okay, and then we'll move forward with the next topics. Okay, so that's all for today, guys. What we'll do is please practice this, okay? And if you guys have any doubt, let me know. I'll send you some more uh, 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 links where you can go and explore more, okay? So this comes for practice only. So if you don't practice and read other materials, you'll not get an idea, okay? You can stop the recording.